This is where most of our work, our effort will go into in the coming months and also years in order to improve our skills in the context of generative AI. So traditional machine learning and deep learning technologies have evolved to a certain stage. They will continue to evolve, but it is uh, generative AI that is going to have the importance of generative AI is going to increase in the coming days. And as students, I think it is a good opportunity for us to understand this technology, learn, and then apply it in our own fields. So it doesn't matter if you're from IT, computer science, electronics, even mechanical, civil, chemical, any engineering domain. In some way or the other, this technology is going to have some kind of importance. So this is a good opportunity for students to understand this technology, experiment with it, get certified also. Again, certification coming from Google in the form of digital badges, so that you will get some use cases where you can apply this particular technology and also understand uh, uh, what are the different ways in which you will be able to utilize it. Okay, so this is where it lies in the overall scope. If you have already studied machine learning or any other similar, any specific algorithm in machine learning or machine learning in general, you will be able to follow what I'm just displaying on the screen. The general difference between predictive or supervised learning approach versus generative approach. The architecture is slightly different, but the outcomes, uh, generative AI systems are more general purpose uh, systems where they are able to we can use them for a wide range of tasks. Okay, so this is actually quite similar to the hardware revolution that we saw in the context of computers also way back in the 70s and 80s, when computers were also when companies started manufacturing computers. Usually computers were only designed for very specific tasks back in when they were first launched, and they were only used for very specific uh, applications in the industry. Okay, then the concept of a PC or personal computer came into uh, the market, and whenever the once personal computer was something that people started to understand, it became a general purpose machine. So it could be used for multiple different tasks, and every household actually started having a computer because of the kind of wide range of tasks that it was able to perform. So similar kind of transformation is what we are seeing in the context of machine learning and AI. Until very recently, we only had very specific machine learning models which targeted very specific predictive tasks. But slowly, we are seeing a shift towards general purpose models where the same AI model is able to perform multiple tasks. Okay, right from creating new content to validation to testing to checking its own output and things like that, and also coordinating with other AI agents and things like that. So even multimodal approaches. Recently, we have seen multimodal systems models that were launched, which are able to handle different forms of data and then merge everything and come up with the results. So that is the transformation, and we are at a stage where we should be able to appreciate both these tracks. Both have their own importance. The predictive model will also continue to grow in the next 3 to 5 years. Predictive model, most to be specific, the other way of saying it is supervised learning. And supervised learning applications in the industry are also going to double in the next few years. In the next 5 years, we will be seeing a 2 times increase in the usage of predictive models. But generative models, which are the ones that uh, can be linked to LLMs and all of these systems, they are also going to increase, but they are going to increase 3 times or 4 times. So the kind of usage that we have right now, it's going to increase by 3 or 4x. So a lot of potential for these technologies in the coming days. And as students, I think it makes sense for us to understand these, and we should know how to utilize, make use of these systems for our any job role that you are targeting. Okay? Uh, Also, there is I wanted to talk a little bit about engineering in specific. So this is a good uh, slide deck, a good way to understand what we are talking about here. Uh, what is engineering in general? Whatever all of you are doing is usually it comes under engineering, but then we are seeing this new concept called AI engineering, where we use AI systems in order to augment the existing engineering tasks that we perform in our day-to-day work, uh, and also in very specific industries. Whatever engineering tasks, it can be the IT industry or manufacturing or any other industry. Whatever engineering tasks are already there, we will start to make use of AI models. In this case, you can also call them as foundational models, the models which are the general purpose AI models that I just spoke about. So these are the models that are going to be integrated with the general engineering disciplines. So general engineering tasks that we have across industries. And we should get used to this, and we should be able to make use of these foundation generative models in our uh, in whatever job role that we take up. So some of the use cases that you see here, things like chatbots, summarization, planning. In case of uh, some use cases, things like fraud detection, even medical use cases like drug discovery, virtual assistants. All of these are some of the areas where AI will augment the regular engineering practices that we already have. Okay? And a more detailed summarization of how this technology is going to evolve in the near future. This, whatever we see on the screen, is already there. Already, many organizations are working on these verticals, but each one has its own importance, and we this is something that we see that is happening. We are calling it the plug and play model, where to any existing task, we are just able to directly integrate the AI model that is fine tuned or customized to that domain. Okay? So, from that perspective, AI engineering becomes a plug and play concept. And in what way can it be plugged in to the existing uh, tasks, and what all options are available in order to perform this is what we have here on this slide. Some of these will be covered in our Google's generative AI learning path. So the most common vertical or use case for generative systems is prompting, where a user can give a prompt, and based on the prompt, the system tries to understand what is the requirement, and it tries to generate some kind of a response which it feels is appropriate for any given prompt. Okay, and you can always improve the level of prompting by uh, advanced techniques. So it comes under prompt engineering, where things like a few short prompting to chain of thought to tree of thought, self consistency, self ask, things like these, which help can be applied in order to improve uh, the output of the system. And this prompting technique is already there for most generative systems, and we can directly use this for various use cases. Okay. So there are other verticals that are more focused on the kind of development that we usually do. So I don't know if you have heard of RAG. It's a new format of application development that is coming up these days. So the regular application development that we know of is slowly getting transformed into this form. And RAG supports usually JavaScript and Python, but more of JavaScript. So retrieval augmented generation. RAG means retrieval augmented generation. And these are systems that are able to um, extract information from uh, unstructured data. Okay, not text data or not structured data that you store in a database, but unstructured data, things like images, videos, or PDF documents, Word documents. Okay, these kinds of files that are not structured, so they can have any random information in them. But these particular systems, RAG systems, are the ones that are capable of querying information from such file formats. Okay, something which was not there before. Okay, none of the current industry practices use this level of querying. We usually use relational databases where data is already in a structured form, text format. Okay, so we are moving ahead of that and going for multimodal approaches to storing and retrieving information. So most of our information systems and web applications are going to be transformed, and a new type of database called vector DBs. Vector databases are the ones which are going to be used uh, for this particular requirement. Okay. So we have to get used to these new techniques. We have to understand these and see how. Again, most of this is done by the AI itself, the foundation model, which is doing most of these. And if we are interested in this approach, there are lots of resources also coming up which will help you to move forward in this direction. Okay, there are other verticals. I won't go into details. There are tools, chains, agents. So these are AI agents, integration tools, things which control the flow of information, reasoning and logic-based agents, and all of these. This is where different frameworks or different agents coming from different backgrounds will communicate, collaborate together in order to solve a particular problem or realize a particular use case. This is an integration level chaining use case vertical. So a lot of framework level uh, applications can be linked to this. There are other things, for example, fine tuning. Fine tuning in this case is trying to improve or fine tune the generative system itself, generative model, by uh, either you can do it through prompt, which is called again prompt tuning. We can do it with RLHF is reinforcement learning with human feedback. So that is where to an existing model, we apply reinforcement learning in order to get the system to learn with additional feedback from our side in order to fine tune its weight. Basically, we are creating the weights of the neural network. Okay. So same way there is LoRa and ETC, etc., and all of that. LoRa is for um, another technique that we use to readjust and realign the weights of a generative system in order to improve its output customized to a particular use case. Okay. Lots of other options. There are infra level use cases. There is monitoring level use cases, safety control level, things like that. So these are advanced, which are very specific to certain job roles. But the most common ones that we have to target are prompting, RAGs, tools, chains, agents, and fine tuning. Okay. These are the four areas that immediately can be targeted for even you as a student. Okay. Now, keeping this uh, context in mind, so Google is offering three different learning paths: beginner, intermediate, and advanced. Okay, beginner is where just the introduction to the technology is provided in the form of videos, and there is one small, four small lab assignments that you will do, and there are cloud credits that will be provided in order for you to complete the labs in all of these courses. We can go through each course in detail so that we can discuss all the modules that exist. Let me share my screen once again. So this is the beginner module, beginner introduction to generative AI, and it is very basic, though it has a lot of theoretical content available if you focus a little on the videos that are provided. So intro to generative AI, everything from the meaning of artificial intelligence to how generative AI has evolved and how does it work, the entire working is all covered as part of this module. Then intro to large language models, the second module, the beginner learning path. The third one, intro to responsible AI. This is just for us to understand what are the responsible AI principles that have to be adopted to develop systems like these. There is a lab module called prompt design with Vertex AI. Vertex AI is a tool, it's a framework offered by Google Cloud, which allows you to directly work with generative AI systems. Systems that will help you to give you access to APIs. They will give you a workbench where you can monitor all the services that you are using, and also they will give you test environments where you can test multiple LLMs, uh, right from prompting to fine tuning to adjustment of parameters, all of that. You can do it both in using a UI interface and also using Python code, using a coding form. So both techniques are covered, and the objective of this module is for you to understand prompt design a little better. What are the elements of prompt design? What are the parameters that we can manipulate and things like that. I give a detailed demo on this as well, but we will be doing it once all of you register, and once you start working on it, we can have another detailed session on these labs. The last module in the beginner learning path is responsible AI. Responsible AI, there is another module, which is the third one. This is just introduction. The fifth module is a very detailed module on the responsible principles, AI principles that we as developers and people who are working or using these tools need to follow in order to make sure that our applications also are uh, built responsibly. Okay? There are some use cases that are identified in this module, usually reports, surveys from different organizations. There is, I think, an organization called the it is a wing of the Economist. It's called Economist Intelligence Unit, and that unit has done a detailed survey on what are the threats as well as what are the best practices that need to be followed, and how industries are actually making use of those principles for the development of generative AI. So it gives us a good understanding of the ethical reasons behind or ethics that need to be uh, employed in order to understand and use these technologies. So beginner path is this. Then we can go into the intermediate path, which is the second learning path. So this is mostly focused on Gemini. Gemini is the LLM a set of LLMs. There are different versions, a set of LLMs designed and maintained by Google. And this intermediate module is focused only on Gemini and how Gemini can be applied to various job roles. Focus is more on the IT and software development industry, but you can apply the same principles or the same techniques to other job roles as well. So the job roles that are targeted as part of this module, the intermediate learning path, is application developers, Gemini, how application developers can use Gemini. Then Gemini for cloud architects, Gemini for data scientists and analysts, uh, the LLM for network engineers, for security engineers, and for DevOps engineers. So this requires a little bit of understanding of the job role first. So this is a good opportunity for all of you to understand what each of these job roles actually means, the kinds of tasks that they perform, and how a system like Gemini will be able to improve the overall outcome of the tasks that these job roles have, okay, be it networking or security, DevOps, application developers, cloud engineers, or even data science. Okay. There is one module on the end-to-end software development lifecycle. So a complete uh, end-to-end review of an entire software development, that is, and how Gemini can augment that development lifecycle. It's covered as part of the seventh module. And then there is GenAI based apps. That this is a lab where we use uh, Gemini to develop generative AI applications. So it's a 5.5 hour lab module that you will have to complete. So this is the intermediate level. It's slightly more advanced than beginner, but on completion of beginner, you will have enough context with you to continue with these modules. Okay? So there is a course completion certificate that you will get for every learning path and a digital badge for every module that you complete. Okay? The last module, the last learning path is the advanced path, which is how generative AI is applicable for developers. So when they say developers, here developers means machine learning developers or machine learning engineers. These are not application developers. So what they mean here is AI or ML engineers and developers. How can generative AI help machine learning engineers or AI engineers to in their work? Okay, so this is slightly more advanced. It is focused only on machine learning and AI engineers, not on any other job role. So for that, because that is the context of this learning path, all the modules that it contains usually talk about the work that machine learning engineers or AI engineers usually do. Okay, right from tasks like working on very specific tasks, like for example, attention mechanism, give me image, how to identify or focus on parts of the image that will give us a more accurate output or result. Okay, so that comes under attention mechanism, encoder decoder part of the transformer architecture, image generation. How can Gemini be used to? I mean, first of all, they'll be introducing diffusion models. Stable diffusion is the framework that we use to generate images, to understand, parse, and generate new images. And after we understand how that does what it does, we will be seeing how the Gemini's multimodal new model, which launched recently, can help us to improve the quality of images that can be generated using the stable diffusion techniques. Okay. So these are very specific to machine learning and AI engineers, but nevertheless, uh, because you are entering into or starting a career in the software as well as in the technology industry, there is a high chance that you might have some overlap with machine learning and AI job roles, which is why this particular learning path will come of use because most of these tasks are what these engineers really work on. Okay? Then there is one module on transformer models and the BERT module. This again, BERT is open source. You can it is publicly available. We will be able to access this model, and we will also be able to query it, test it, and relate it to the general transformer models that are available. There is a simple use case for image captioning. So how do image captioning models work? Given any image, how does it understand what is there in the image and use deep learning to convert it into some description? Okay. Actually, this task is also covered in the beginner level. There is one lab where you give an image to the generative system and it is capable of describing the image. Okay, so that task is already covered in the beginner level. But in this module, we get into more details of what is happening in the background. Okay, step by step approach to what we will try to uh, break down all tasks and then understand each of those steps independently. Okay, so all of this is done using the transformer encoder decoder uh, architecture that was covered in the third module. And the same thing will help us to understand how these use cases are, uh, I mean, how Gemini can be used for these. Then Vertex AI Studio. Vertex AI is again a framework, a platform, a kind of a product. Vertex AI Studio is a very specific tool which is used for customizing generative AI models. Okay, so if you want to fine tune an existing model, an existing foundation model, we can do that in multiple ways. Like I discussed in one of the slides, there is prompt tuning, there is fine tuning using um, reinforcement learning with human feedback, there is Aura that we can use. So different ways in which an existing foundation model can be customized or fine tuned. So that can be done using this tool that Google has already given access to us through its Google Cloud platform. It's called Vertex AI Studio. Okay. And we will get to play around with this product and we will be able to fine tune some of the existing test models that are available on Google Cloud. Last few modules are focused on vector search and embeddings, whatever I discussed earlier in the slide deck. Uh, Vector databases and vector searches are ones where you can build search applications that use LLMs and to search for embeddings as well as perform vector search. And you can also bring in the concept of the databases in this uh, module. Okay. The next one is the RAG or retrieval augmented generative systems that I also discussed in the previous slide. So how to extract information from rich documents. And we'll be using Gemini's multimodal model to give it documents and then extract information from these documents. So it is not just simple extraction using OCR and all of that, but it is a bit more than that because it is able to, the document doesn't only have to contain text, right? The document can contain images also. So it is able to perform multimodal analysis of different types of data in any rich text document like Word or PDF, and it is still able to come up with a comprehensive understanding of what exists in it. Okay? So that is a good example lab. This is a lab that you will be working on as part of the 8th module. Then responsible AI for machine learning and AI developers. So this is specific to people who are trying to develop LLM systems, not the people who are trying to use systems. So what we studied in beginner for responsible AI is for people who are using generative systems. This module is focused on the people who are developing LLMs and generative AI systems. The focus has to be on fairness and bias has to be minimized. And this is something which is given a lot of importance. And we will be seeing how what are some of the best practices, and also a lab which allows you to understand process. Okay. Then two other forms in terms of responsible AI called interpretability and transparency. These two are also added as a different module, again only for machine learning and AI engineers working on developing AI products. Last module is for machine learning ML ops, so machine learning operations for generative AI. So we concluded it's a small module, just a 30-minute module that will complete in order to get an certificate on the advanced GenAI learning path. Each module you will get a digital badge, and on completion of the learning path, you will get a certificate. So, certificate, when I say certificate, it is not a certificate where your name is printed on it and date and all of that. Regular certificates that you're used to, it doesn't come like that. So, certificate is linked to your Google account. So, whichever Google account you use, complete these modules. That Google account will have a public URL where all your certificates are listed. Okay. What you have to do is you have to use that public URL in your resume wherever you want to project yourself, maybe in your LinkedIn or any social media platform. You have to use that public URL where all your certificates and digital badges are in one place in a single web page. Okay. So that's how it is to be. And anyone who wants to verify your work, they have to just go to that URL and your public profile will be accessible to them. This is what we have as far as the content goes. I will give the control back to Mr. Srikanth to continue with the next regarding the next steps. Thank you.